Hi. So in this question, we've been told that the roots of this equation are p, q, and r. And without solving the equation, we've been asked to find the value of these three expressions. So the first thing we're going to do is mark on a positive and negative coefficients. We know this 5 will be the product of p, q, and r. The positive 4 will be pq plus pr plus qr. And the 2 will be the sum of the roots, p plus q plus r. And then part A, to work out this expression, we need to use a combination of these three values. So the first thing we can do is we can pull out this 2, so we get two lots of 1 over p plus 1 over q plus 1 over r. Now we can make this expression by dividing pq plus pr plus qr by pqr. Can you see that these pq's will cancel with this one to leave us with 1 over r? These PRs will cancel with these two to leave us with 1 over q, and this q and this r will cancel with these two to leave us with 1 over p. And we know this value is 4 and pqr is equal to 5. And this will be two lots of 4/5, which will be 8/5. So that's part 1. For part 2, probably the quickest way of doing this is to expand out each of these three brackets. So we'll begin with expanding p minus 4 by q minus 4. So we get this multiplied by r minus 4, and then we'll expand out each of these terms. So then we have PQR, we've got the product pairs, and we've got the individual roots. So we can simplify this. We'll pull out the negative 4 for the product pairs, and we'll pull out the positive 16 for the individual roots. And then we have this constant of negative 64. Again, we can substitute in these known values here and here. And we can work this out, and we get negative 43. So that's part B. For part C, there's a couple of ways of doing this. The way I'm going to do it is I'm going to substitute p, q, and r in place of x for this expression. So we'll get this when we substitute in p, this when we substitute in q, and this when we substitute in r. Now, because each of these three are equal to 0, we can add up the expressions and their total sum will be 0. So now I'm going to separate this in terms of their powers. We've got the cube terms, the quadratic terms, the linear, and the constants. So we'll put our cube terms together, and then for the squared terms, we can factor out this negative 2. So we'll get negative 2 lots of p squared plus q squared plus r squared. And then for the constant terms, we can pull out the positive 4. Then the constant will just add to make negative 15. So because we've been asked to work out the cube terms, I'll move all of this to the left-hand side, and I'll substitute in the value we have for p plus q plus r. Okay, so now we need to work out the p squared plus the q squared plus the r squared. So if I just underline this in blue and work this out separately, we can get this by squaring p plus q plus r. When we square this, we multiply it by itself. And this will give us, so now we've expanded the brackets out, we can separate them in terms of their powers. We've got the squared terms, and we've got two lots of each product pair. So here's PQ, and again, PR, and again, and QR and IQ. So we can simplify this as all of this. And then we can substitute in these values. So therefore, p squared plus q squared plus r squared will equal the 4 minus the 8. So negative 4. And then we can substitute this value back into here. So we'll get negative 16 plus the 15, which gives us negative 1. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe. And you can download lessons on roots of polynomials from my website, mrmathematics.com. I'll leave a link in the description below.